All right, let's talk about cloud security. Today, we're diving into a really fundamental question. How do you make sure your private services can talk to each other without ever touching the dangerous public internet? We're going to break down exactly how it's done in the AWS cloud and why it's so important for keeping your data safe. So, think about this common scenario. You've built this secure fortress for your apps in a private cloud network. But what happens when they need to grab something from outside that fortress, like, say, from cloud storage? Well, the default way is often right across the open public internet. That's kind of like asking a royal messenger to carry a secret scroll through a crowded, chaotic marketplace. I mean, it might get there, but is it really secure? That's the core problem we're solving. How do we build a truly private, secure bridge for our data? To really get a grip on the solution, we first need to see the problem in action. So let's build a simple little sandbox environment. This is going to be our foundation, and it'll let us see exactly what's going on under the hood. The cornerstone of our sandbox is the Amazon VPC, which stands for Virtual Private Cloud. Now, the best way to think about this thing is like having your own private, gated community inside the huge city that is the AWS cloud. You get to set the rules for who comes in and who goes out. You decide where all the roads go. It's all about creating your own isolated, secure bubble for your stuff. Our setup here is super simple. First, we build our private fenced-in area, that's the VPC. Second, we put a virtual server, which is called an EC2 instance, inside that fence. And third, we've got our cloud storage, an S3 bucket, which lives outside the fence in the public cloud space. The whole puzzle is figuring out how to create a secure connection between the server inside and the storage outside. All right, our sandbox is all set up, so now let's see what happens when we try to connect our server to the storage using the default method. This is where we run smack into what I like to call the public internet problem. For our EC2 server to even talk to S3, it needs permission, right? And we give it that permission using access keys. You can really just think of these like a username and a secret password that an application uses to log into your AWS account and start messing with your resources. Okay, so we're logged into our server inside the VPC, and we run a really simple test. We're basically just asking AWS, hey, can you show me a list of all my storage buckets? It's a simple check, just to see if we can even make a connection. And it works. Just like that. The terminal shows us a list of all our S3 buckets, so connection made. But, and this is a big but, how was that connection made? That's where the real problem is hiding. And here is the crucial insight from the source material. That successful connection didn't just go to our one specific S3 bucket. Nope, it went out over the public internet and connected to the main AWS network. Think of it like this. You've just opened a door to the entire AWS universe when all you needed to do was peek into one single room. From a security standpoint, that's just way too open. So, how do we fix this mess? Well, that brings us to a really elegant solution. We're going to build a private, secure tunnel that completely bypasses the public internet. And this leads us to a super important principle in security. Just because something works, that doesn't mean it's the right way to do it. There is a much more secure path for our data, and it's time we build it. And here it is, the hero of our story, the VPC endpoint. Just look at how this changes the game. Instead of going out into the chaos of the public internet, the VPC endpoint creates a direct, private tunnel from our secure VPC straight to the AWS service we need. Traffic never ever leaves the safety of the Amazon network. It's like having a private, underground passage instead of using the public streets. Now, for our specific task of connecting to S3 storage, we use what's called a gateway endpoint. You can just think of it as a special type of tunnel that AWS purpose-built to handle huge amounts of data, which makes it the perfect tool for this job. Okay, so we've built our private tunnel, but how do we make sure it's the only way in? In this next section, we are going to lock that old public door and make everyone use our new secure entrance. The tool we're going to use to lock this thing down is a bucket policy. This is basically a set of rules that you attach directly to your S3 bucket. It acts like a bouncer at a club door, and it decides exactly who gets in, and crucially for us, from where they're allowed to enter. And the rule we give our bouncer is beautifully simple and incredibly powerful. It says, deny everyone at the door. Unless, and only unless, they come through our new private VIP tunnel. No exceptions. The public internet entrance is now officially closed for business. Now, this is where the person who wrote the source material had a real aha moment. Immediately after saving this new policy, they went to view their S3 bucket in the normal AWS Web Console, and suddenly they were just hit with access denied errors. What happened? And the answer is just brilliant. The policy was so effective, it blocked everything that wasn't using the private tunnel. And that included the author's own connection from the main AWS website, because that uses the public internet. The bouncer was doing its job perfectly, which proved the new rule was working exactly as intended. And now for the final test. Let's put our new, secure setup through its paces and prove that this private tunnel is officially in charge. So we're back on our server inside the private network, and we're running the exact same command as before. We're asking to see the list of storage buckets. But now, with that public door locked, will our request actually get through using our new private tunnel? And success! The command works. This really shows the difference, right? We've gone from that chaotic, messy public internet route to a clean, direct, and secure private tunnel. We've proven the connection is not just possible, but now it's completely private. But we can get even more granular. What if we want to temporarily close our private bridge, maybe for maintenance? Well, the endpoint tunnel itself can have its own set of rules. We can add a rule right on the endpoint to explicitly deny all traffic, which basically closes the main gate to our own secure bridge. We run our command one last time, and as you'd expect, access denied. The command now fails. This is the ultimate proof. Our endpoint is now the single point of control. It is the gatekeeper for all communication between our private server and our S3 storage. We have total granular control. And that really brings us to the key takeaway. We just closed one very common but often overlooked door to the public internet. It's a powerful reminder to think critically about how your cloud services talk to each other. So the final question I'll leave you with is this. What other doors in your own cloud environment have you left open by default?